So can you ask that one more time?
Yeah, about the standard student T distributions.
Uh-huh.
Um, so what are the numbers in the chart? Are they the number of standard deviations from the mean?
No, they're just they're the actual values of the random variable, and the percentages are up at the top. No, they don't represent like the number of standard deviations, which is, we discovered that was exactly what the z-scores were doing, right? But unfortunately for the t distribution, that's just not true. It starts to become more and more true as the number of or as the degrees of freedom goes up. But that's because why? What did I say about the t distribution as the number of degrees of freedom goes up? What did I say starts to happen? What does the distribution look like?
The normal.
Yeah, right. And so if it gets closer and closer to the standard normal, then you know the standard deviation has to be getting closer and closer to 1. And at that point, the t values are just the number of standard deviations away from the mean. But the t values in general, it really can't be, right, Rachel? It can't be the number of standard deviations. Otherwise, the distribution would look just like the standard normal distribution, right? I mean, because it would basically be 1 to the left and right. You would have exactly 68% of the data. And then 2, between -2 and 2, you would have exactly 95.7. And it would have to behave exactly like the standard normal distribution for it to actually be the number of standard deviations. They're just the values of the distribution, and it does get closer and closer to what the z was doing as the degrees of freedom goes up. Does that kind of help?
So they don't really represent anything by itself.
No, they're just the value of the random variable. Yeah, that's it. They're just the value. It's kind of like if I asked, you know, if I said, what's the probability that, you know, the Poisson random variable x is smaller than or equal to 7? Well, what does 7 mean? Well, it's just a value for that random variable. Does that make sense? Hopefully.
Yeah, I think so.
Okay. Yeah, I was gonna here. Let me, because I kind of let me actually go here. I'll just show you this real quick. So wasn't I working with this in the lecture? Was this the table I was using?
Yeah, that's it.
Okay, so I was gonna here. Let me draw a quick picture just to show you like what all of this stuff is doing. Okay. So hang on a second. I'm gonna turn off my second camera here. There we go. Okay, so like when I computed this number right here, 0.905 whatever, okay? This is basically like me saying, see, there was like an 80% right here, and the degrees of freedom were 6. So this number that I'm getting right here is a number that says, you know, below this is 80% of the data. So let me draw a picture here. So below this, okay, so this is a t distribution with degrees of freedom equal to 6. And what they're saying is, okay, 0.906 basically. What percentage of the data is below this? Well, 80%. Okay, that's what that number is saying, which is why we have these two things right here. This computation right here that I kind of had to backtrack on a little bit. Says T distribution two tail. Okay. T distribution two tail 0.906. What in the world is this thing doing? Well, it's doing this. It's like saying, okay, if I had a T value of 0.906, and by the way, we're still in the degrees of freedom equal to 6 situation, then I would reflect across to the symmetric opposite thing, and it's saying, okay, what's the probability in the two tails? And what's the answer to that question? What's the answer to that question, Rachel? So if I have 0.906, what percentage goes to the left of 0.906 based on what we've already seen? What percentage?
9.4.
Well, no, it's 80%, right?
Okay, yeah.
It's 80%. And what percentage would there be up here in the upper tail?
So it's 80% in the center.
No. So 80% is what we discovered was to the left of this thing. Yeah, that's what that.
Okay, then 20
That's
to
true.
the right.
So there would be 20% to the right. Does that make sense?
Yeah.
20% to the right, what percent would be down here? Well, another 20%.
Right.
The answer ends up being 40%. Does that make sense?
Yeah, it does.
Okay. Yeah, I mean it's a little bit tricky how they talk about it. You know, when you try to put this thing in, it says T distribution two tail. But what this is saying is if I look at the T distribution and I look at this value 0.906 for 6 degrees of freedom, how much probability would there be above this value and in the symmetrically opposite ended tail combined? And the answer is basically 40%. Does that kind of make sense? It's a little bit tricky to get a handle on it first, but that's how these things work.
Mhm. When would it be useful to know only the center and not like and not know just to the left of the one dimension versus two?
Yeah. So I mean, the reason it's helpful to only know the center is because we're going to use it in a confidence interval context, and we're only going to want to talk about the percentage of data in the center when we do that. And the T distribution is almost exclusively built to help us in the confidence interval context. Okay.
Okay.
So that's why this thing gets reported in this weird way. It's like used exclusively this way, and so that's why it gets reported in this weird way. Whereas the normal distribution gets used so widely that they don't necessarily report things the same way they do for the T distribution. So hopefully that kind of makes sense. Anything else?
I think that was it.
Okay. All right. Well, hey, I'm always glad when, people come by and at least ask a couple good questions. I think that benefits everybody. So thanks for doing that.
Yeah, thanks.
All right. Well, I guess we could call it a day then or something.
Okay. Thanks then.
All right. See ya.
Bye.